Good morning, students. Just 2 more minutes and we'll start it. Let people join as we are into the last week of the semester end. So not more than 2 minutes. Good morning. Yeah, people are joining. Yeah. Meanwhile, I will share the screen. Just 2 more minutes and we'll start it. Yeah. By one more thing, by this weekend, I guess that Thursday, I'll finalize all your marks because Wednesday you have from Thursday. I guess you have third eye. The complimentary only for compensation only for the people who have missed either of the eyes, okay, and that too with a genuine reason. So after that, by weekend I'll just freeze your marks. Just make sure that you have a look in your Google Forms. I'll share in WhatsApp also, okay. No issues. Yeah, how many are there? Yeah, early Monday morning is always a hectic one. Okay, no issues. Shall we wait or shall we start? Hope the screen is visible. Asif, if you can reply again. Is the screen visible? Okay, fine. Thank you. Yeah, without wasting much time now, we'll start it, okay? As I said, this chapter is very easy, which almost deals only with the syntax and the block diagrams, okay? So in the previous class, we said about the FIFOs, okay? We said about pipes, what pipes are used for. Pipes are used for communication between two related processes, okay? This was very important, between the related processes. Then we said about the programming code, like what happens when a parent sends a message to the child and what happens when a child sends a message to the parent. We saw the program also. Then we said about the P open, the drawbacks of pipe, that were like opening a pipe, closing a pipe, opening the correct ends, blocking the other end. All these drawbacks were overtaken by the functions P open and P close. We said about that also, what is a P open and what is a P close. After that, we said about co-processes. When a program, a filter reads its same inputs and displays its same output, is called as a co-process. That also we discussed. Then we said about the FIFOs, very important. The drawbacks of pipes, that is the information which can be shared between related processes is overtaken by pipes. Sorry, FIFOs. FIFOs can be used for communication between two unrelated processes. That is what we studied. And usually, as I said, this is usually asked in the exams. Explain the client-server communication for FIFOs. Then you should clearly explain this. I told in the previous class what happens. Clients always request to the FIFO, well-known FIFO, which is a MK FIFO which is created. So server will read from that FIFO, and when a server wants to respond, it will not respond to the well-known FIFO. It will respond to the client-specific FIFO, because every client should get a specific information. That is what client writes request to the well-known FIFO. Server reads it from the well-known FIFO, and server writes its replies to client-specific FIFO, and client-specific FIFO will read the replies. This is what we studied in the previous class. So the limitations of FIFO now. After knowing all this, what are the limitations of FIFO? The limitations of FIFO are, for any kind of data transfer through the pipes, there must be at least one reader process and one writer process running, which means that whenever you are talking about a FIFO, there should always be two processes running for you. One is the reader process and the other one is the writer process. This is one of the limitations. If either of them are down, you can't implement a FIFO. Please make a note of it, okay? And the other limitation is, the data which is being exchanged between the process should be of the form of stream of bytes only. The information which is being exchanged is in the form of bytes. So the limitations of this was overtaken by another factor of XIPCs, which are nothing but message queues, semaphore, and shared memory. Please make a note of it. Just like pipes, just like FIFO, these are also inter-process communication means, which is nothing but message queues, semaphores, and shared memory. The only difference here is the semaphores and all what we are doing here. They are used for inter-process communication where information is passed in terms of messages, not in terms of stream of bytes. So the limitations of FIFO, which are those limitations? That is, for every time there should be one active process. Both should be active, that is reader as well as writer, that is the client and server. If only either of the process is active, you can't implement a FIFO. Yeah, and the other is the information which is being exchanged in FIFOs is in the form of stream of bytes. So these are the two drawbacks of FIFOs. So the drawback of FIFOs are overtaken by, again, system 5 supports again different system calls for inter-process communications. Those are message queues, semaphores, and shared memory. So here, what kind of questions can be asked here? They can ask you explain message queues with all its APIs, explain semaphore with all its APIs, explain shared memory with all its APIs. We'll study in the upcoming slides, okay? So what are all these? Message queues. So message queues is one. It allows one or more process to write message which will be read by one or more reading process. Just like a broadcast message, you can say. In client, how it was only one process which was writing and it was the other process which was reading. But in message queues, it allows one or more processes to write message. So in the message queues, one or more processes can write the messages which can be read by one or more reading processes. So there it was only one, but here it is more than one. This is how exactly message queues helps in inter-process communication. And the next one is semaphore. Just like what you studied in your operating system, it is used for process synchronization purpose. That is, it is a resource that contains an integer value that allows processes to synchronize by testing and setting this value to a single atomic operation. That means it assures that when the process that tests this value of a semaphore is set to a different value and not other processes will interfere with that operation. But in client server, how it was? I had to write to the server and server response. But in semaphore, what happens here is semaphore is used for process synchronization. That is, at the same time, both should be enabled or both should be active. Synchronization means it should be in a inline. So what happens here is it is used for process synchronization, that it contains an integer value which allows process to synchronize, which means that only for that single value for that process is changed and not other process will interfere with that operation. If anything is going with other operation, it will not be interfered. And the last concept is shared memory. As we all know what is a shared memory. Shared memory is nothing but is a block of memory in the address space shared by two or more processes. When two or more processes share the same block of the memory, it is called as shared memory. That is, if one process makes a changes to this memory, then it is visible to all the processes accessing the memory. That is what we have seen in the banks also, DBMS, like transaction concept. So what happens is, if one or more processes are accessing the same memory, if either process makes the changes, the other processes which are accessing the memory will also be seen the reflection or the changes occurring. So these are the three different means for which we can again go for inter-process communication. So now let's study one by one in detail. Usually they ask everyone for 8 or 10 marks, like explain message queue with all the APIs, as I said, semaphore with all the APIs, and shared memory with all the APIs. So these are the different means of inter-process communication. I repeat, message queue allows more than one process to write message. You'll understand with the APIs how exactly it goes. And and that the same messages will be read by one or more reading processes also. Semaphores, it is used for process synchronization. That means when two processes wants to synchronize, this sets an integer value saying that only the changes can be done to that processes and other process will not interfere in that. And shared memory is when the same memory is shared by two or more processes, and if one process makes the changes to this memory, then all other processes accessing the memory, the change is visible. Okay, so let's study one by one in detail. Now, what are message queues? They are similar to FIFOs, that is, it allows two or more processes to exchange data. Yeah, they are like FIFOs only, which says that they allow two or more processes to exchange data. But not FIFO, message can be retrieved out of order also. You don't have to be in the same order. They can be retrieved in out of order also. And message queues remains undeleted until you delete or you reboot the system. So here you don't have to open a FIFO or close a FIFO, just like what we did in pipes, we open and all. FIFO also, we open a FIFO, we can close a FIFO, but message queues remains until you delete or you reboot the system. So what does message queue do? So message queue provides an easy and efficient way of exchanging data between two unrelated processes. Please make a note of this. Message queues provide an easy and efficient way. Just a minute, I'll just post the questions once here. Okay. Message queues provide an easy and efficient way of exchanging the data between two unrelated processes. Then what is advantages with message queues then? So the advantage of message queues over pipe is that message queue is independent, that is of both sending and receiving process. This is very important. So when message queues are used, they are used for efficient way of exchanging data between two unrelated processes. The advantage with message queue is it is used where the processes are independent of sending and receiving, which avoids difficulties that occur in synchronization, that is opening and closing of named pipes, that is open a pipe, close a pipe, not necessary only to do that with the message queues. And the priority of messages can be sent and received. And the other important thing is message queues are used to send and receive data with a block of data between two processes in terms of messages, but there it was in bytes. So here it will be sending the data in terms of block of data, which we call it as a messages. So here each message has a specific type for which the receiving process can have any value independently, which means that whenever a message queue is used, it is used to communicate between any two processes and it is independent of each other. So this was the introduction about message queues. So what are message queues now? So message queue is like a linked list of messages stored within the kernel memory and identified by a message queue identifiers. Just like a linked list which has a data and a node field, right? So where it stores the information and the node field indicates which block you are accessing. So here we call it as a message queue identifier. So each message queue has its own identifier. As I said, each value of the message queue is a unique value which can be used for further communication. And messages within the queue can be of different types. So when there is a message in the queue, they can be of different types. One queue can be used for to get the messages, one queue can be used to send the messages, and one queue can be used to receive the message, that is fetch messages. So in message queues, usually there are three APIs. One is message get, another one is message send, and the third one is message receive. We'll study all this in detail in the coming slides. Okay. So what exactly is a message queue indicates? So whenever you're talking about a message queue, it has a data structure, MSQID_DS, which has few of the members listed, which are shown here. That is the first one. Message queue num underscore t is nothing but the message of the queue. That is the number of messages in the queue. How many messages are there? Whether there are one message, two message, and all. Message length indicates maximum number of bytes on queue. So what's the maximum number of bytes that can be transferred over queue? PID underscore T, MSG underscore LSPID. That is PID of the last message sent. So messages are being sent and received in the queue, right? In the linked list. So what was the PID of the last message sent? What was the PID of the last message received? What was the time when last message was sent? What was the time when last message was received? And what was the time when last message was changed? That is the study, right? In the file C. Last access time, last modified time, last change time. Right? Similarly, this is a data structure, or we can call it as a structure for which we'll work with the message queues. So we'll study one by one in detail. MSG get. As I said, this chapter is all about syntax only. So MSG get is nothing but this function is used to create and access a message queue. This function MSG get, and all are found in the system file or header file. This /msg.h. So what is a MSG get? It writes an integer value which is helpful to create and access a message queue. Look at the members here. Message queue has two parameters. The first parameter is nothing but the key value, that is the name of a particular message queue. So which message queue you are using, what is the name, that is nothing but the first parameter. And the second one is nothing but a flag that is consist of the permission flag, which means that whether you want to create it or you want to ignore it, right? So the permission indicates with the permission to create a message queue. So whenever you want to create a message queue, you have to use the system called MSG get, which has two fields. The first one is nothing but the value that names a particular message queue, and second one is the flag which specifies the permission for each message queue. Okay, and it returns the message queue ID if okay, and -1 on error. As I said, everything returns the value. So whichever message queue is executed, it writes its integer value. It writes its integer value on successful execution and writes -1 on error. So this is the system call used to create and access a message queue. The next one, once a message queue is created, now the next comes is MSG send. This function allows to add messages to the message queue. Please make a note of it. MSG get is used to create and access a message queue, whereas MSG send allows to add messages to the message queue. Okay, look at this now. Now MSG send has 1, 2, 3, and 4 parameters. So what is the first parameter? MSQID is nothing but the internal ID of the message queue in bytes. So whenever you want to send a function or add a message, you will always specify the message queue ID to which message you are adding it. And the second argument, that is PTR, is an integer that contains the positive integer value that is immediately followed by the message data, which means that whenever you are creating a message queue, the positive value indicates the next message which you are targeting, or the next message followed by the data message. And again, the flag value is nothing but which specifies the which specifies whether the message queue is waiting or it is not waiting. We have like wait or no wait system call, which tells me that whenever you want to create a message queue, or when you want to add a message to the message queue, now you have created a message queue by the system call MSG get. So once you get that, now that should be added in the message queue. That can be done by the system call MSG send, which allows to add message to the message queues. Okay. Here, look at this part now. the message queue structure, whichever is there, is defined by two members. The first one is M type, which means that the positive message type, and the second one is a message text, that is nothing but the message length in terms of bytes. So the MSQ ID, which we are talking here, this one I'm talking, is nothing but the message queue identifiers returned from MSG get function. Please remember, see here, once this MSG get is executed, it returns the message queue ID, right? It returns the message queue ID. So whenever you want to send a message queue, you are creating a message, you want to send in the message queue, you have to first create it. So MSG get will create a message queue. Once executed successfully, it writes an integer value. That integer value is returned by that function because it returns a message queue ID, and that message queue ID is nothing but it's sent here, which means that now message queue you have created. You have created a message queue. So once you create a message queue, now you have to send it. You have to allow that to add message to the message queue. That can be done by the system called MSG send. So the first argument is nothing but the message queue identifier returned from MSG get function. So once I'll create it, then I'll send it. And MSG PTR, or that is PTR, is a pointer to the message to be sent in the size of message pointed by MSG pointer. So it shows that which is the next block of data you are reading it. And the size must not be included as long int or something. An MSG flag controls what happens if the current message is full or the maximum limit of the size queue has been reached. That means, since I said the queue size is predefined, the size is already reached, then flag indicates what should we do, whether it should be wait till the message is sent and next message arrives, or it should ignore it. So please remember that everything is in a flow. Okay, first you create a message queue by MSG get. If created successfully, it writes an integer value. That integer value is nothing but it's passed here for the data, and the flag indicates if the message queue value is full, what should be done for the other process, whether it has to wait or it has to return immediately without sending the function. That is what it says. Message queue ID or zero or more process, it can wait or it can show an error. That is, either it can wait for all the process to execute or it can ignore it. So once this message sent is done, then next comes is message receive. This function retrieves, just a minute students, main officer. Umesh sir, thank you. Yeah. Next is MSG receive. Now what does this function do? This function retrieves message from a message queue. Please remember, this is you're creating a message queue. This is you're sending the message to the message queue. Please understand students, okay? Don't get confused. MSG get will create a message queue. MSG send will send the message to the message queue. And MSG, okay, and MSG receive will retrieve the message from message queue. Now we have already created a message queue. We have sent, just a minute, so okay. You have created the message queue by get message. Then you have sent it to the message queue by send message. Then once you send it, now your task is to read the messages. So reading of the messages can be done by the system called MSG RCV. So what does this do? This will receive messages from the message queue. Now you created the message queue, you send it to the message queue. Now your next task is to read from the message queue, and that can be done by the MSGRCV, that is message receive. So again here it has few of the arguments. See students, that is, see here, look at the data type here. Okay, this will write its positive value. So when you're receiving it, you receive in terms of bytes size. Okay, message received. The first argument is MSQID. It is a message queue identifier returned from MSG get function. So once you have created the message, you can receive the message on the message queue by the first argument, which is nothing but the message queue identifier returned from MSG get. Okay, and the next argument, pointer. Message pointer is a pointer to the message to be received, which indicates which message is yet to receive. Okay, and the third argument, size underscore t bytes, n bytes, is the size of the message pointed by the message pointer, which means that how much amount of message can be read from the message queue. And the last one is long type, which allows reception of the messages. And the last one is the flag. Again, the same thing. Flag controls what happens when no message of the type is waiting to be received, which means that you're trying to receive a message and there are no messages available. There are no messages available to read it. So this is what happens when you want to read the messages from a message queues. It retrieves a message from the message queues. N bytes is nothing but the size in bytes of the text portion, which is pointed by the PTR. So from the message, whichever it is point, it reads that message, and the pointer is a pointer. PTR is a pointer to a structure that will hold the message retrieved from the message queues. So these are the three variations. See, they can ask you what is message queue. You can have to. I'll just again go back here for your understanding. They can ask you what is message queue. It allows one or more processes. See, there are n number of message queues available, and n or more processes are writing to the message queues, and n or more processes are reading from the message queues. Okay, so this is what it says. It allows one or more processes to write messages which will be read by one or more reading processes. So for you to write into the message queue first, you should create the message queue. It is created by the system called MSG get. So this will create the message queue. On successful execution, it writes the message queue ID which was created. After that, you need to send that message queue to the message queue. So that is done by the system called MSG send. This will send it to the message queue. So after sending this, you need to receive the information, and the information is received by the system called MSG RCV. Again, here the first argument is nothing but the message queue ID which was created by MSG get system call. Pointer is nothing but it points to the message to be received, which message is being received. The size is nothing but the size of message pointed by the message pointer. So how much is the size of the message? And the next one is type. It is nothing but the which are the messages received in the queue. And the last one is message flag, which controls what happens when no message of this type is waiting to be received. Again, there is a wait or no wait flag and count. I hope the other day people have some batch showed me how to implement a message queue that already executed a message queue. First, you should get. I am having a sample code also, which I'll share with you later on, which will tell you first what message should be created, how it should be sent to the message queue, and how it can be received from the message queue. So now we studied how to get a message queue, how to send to a message queue, and how to receive from a message queue. And the last one is MSG CTL. Now what does this do? This is very important. This is used to control the message queue. Since you have studied the message queue is a structure which has n number of members in it. So a message queue can be controlled by the system called MSG TTL. Again, this function has the same thing. First one is MSQ ID, which is nothing but the message queue ID, which was created by the message get. The second parameter is the command. Now command is nothing but the action taken. What action you want to take on the message queues. Okay. And the various commands here are this one. First one is IPC underscore stat. Now it fetches the message queue ID data structure for this queue. So for this specific message, what information you want to fetch it is nothing but the command you want to perform it. So here, if the command value is IPC underscore stat, it fetches the message queue ID for this queue. So whichever queue is specified there, for that it fetches the message queue ID. And if the command value is IPC underscore set, now what does it do if it is IPC underscore set? It is used to set the value associated with the message queue to those provided in the structure pointed by buff of the type MSQ ID. So here, if this command value is IPC underscore set, then it sets the new value to the one which is specified by this structure variable. Now, what is this structure? Again, I'll go back here. Structure is this structure. So whatever the values you have specified in this structure, those are taken and assigned to this message queue, which is got from the MSG get system call. Okay, if the command value is IPC underscore set, and if the command value is IPC underscore RMID, it removes a message queue from the system having the ID MSQID, because as I said, you can't delete it until you reboot it or you restart the system, right? So if at all you want to remove a message from a message queue, then this control, MSG control, will do that. It will fetch all the data structures for this queue. Now, which all data structures? See, for example, we'll create this message by message get. Now message queue is created. So for that, what are the values? What is the size of the message is given by MSQID data structure. Maximum number of bytes in the message is given by this. PID of the last message sent, PID of the last message received, last message time, last message received, last change time. All these are the data structures for that queue, like properties of that message queue. If at all you want to control that, you can do it by the system called MSG CTL. This will control. If this command value is IPC underscore stat, so whichever message queue was created by MSG get, for that it will fetch all the values. It will fetch all the values. Okay, which are those values I'm talking here? These values: the number of message queues, the maximum bytes, the PID, and all it will be fetching if this command value is IPC underscore stat. But if the command value is IPC underscore set, it will set new values. That is the new number, new last sent, last received, and all that for the message queue which was specified here. And if the command value is IPC underscore RMID, then it removes the message queue from the system or any data on the queue. That is, whichever the message queue specified here, for that it removes the information of that. So this was for the today. I hope this is clear. Again, similar, we have shared memory and semaphores. Again, same thing. Usually if you look at the previous question, but it is explain message queues with the APIs available in it. So each API you should list it, explain it, and do it. So usually it is asked for 8 to 10 marks for that. Okay, so we'll stop it for the day here. Just a minute, students. I hope no doubts now. Yeah. Okay. So this was all about message queues, only one. So tomorrow you have network class at 10 o'clock. I have requested sir, and I'll be taking his class, and he'll be taking my class on Thursday. So tomorrow I'll just try to wind up the remaining 2 units. Okay. Please answer me this. Give the attendance for me. Again, I repeat, students, this unit's notes I don't have. Okay, I had only the handwritten notes of first 3 units, but the PPT will help you out to understand it. No worries in that. Okay. Again, one more thing. Umesh sir will start his class at 10:45 only. Okay, please make a note of it. After this class, Umesh sir will start the class at 10:45 only. Okay. So please give the attendance and you can leave the class and join CN class by 10:45. Okay. Thank you everyone. Have a nice day.